Hi, Advanced Algebra 2. I'm going to give you just some pointers on how to get started on your quadratic inequality systems art project. So in this, you're going to use four quadratics and graphs of those, four parabolas, and create a picture. Now, sorry, these are my dogs in the background. People go at this two different ways. Sometimes people think of something that they want to create, a logo or a picture or an animated character, and then they construct the quadratic equations in order to make the curves that they need. You know enough about quadratics to do that. So you've been working in all the different forms: vertex, standard, and intercept form. And so, especially with vertex form, you can place quadratics where you want them. So I'm just going to give you a few hints on how to do that and to help you get started and make sure you make good progress on the work days for your project. So you want to have at the end, with your four quadratic equations, one that's in standard, one that's in vertex, one that's in intercept form, and then the fourth one can be a repeat of any of those. You want to have at least one inequality that's narrower than the parent, one that's wider, one that opens up, and then at least one that opens down. And so you're going to recall just where we were learning about graphing those quadratics. And for example, the A value will be greater than 1 for the graph to be stretched and it to be narrower than the parent. It'll be less than 1, the value of it, to be wider or a shrink from the parent function. You know the A value will be positive for it to open up and negative for it to open down. It's very important that you make sure you complete all parts of this project. So this worksheet is a good bit of the points for the project. Here's the little rubric. So you'll need to write the four equations and graph them on the back side of your sheet here. So the equation in the correct form goes here. You need to fill in all of these values, and you can use what you know about the different quadratic forms and also Desmos to help you locate these values. So each of those forms. Then I have provided graph space. I need to have the XY axis is marked for you, but I need to have accurate scales on all four of these, and then all four of your quadratics graphed separately. After you do that, then you will, on your art paper, create a grid and then put all of those graphs together, creating a picture, and then make sure that you have some color and creativity and neatness in your presentation. What you want to be sure is that in your picture, I have left some examples and I've shown you some in class. You don't have to just graph the whole parabola. You can graph the part that's going to be a part of your picture. You will need to make sure that you label these somehow on your graph, so either writing the inequalities or numbering them. Now let me show you how Desmos, or you could do this on your graphing calculator as well, will help you get started. So go to Desmos once you're on your computer, and then I would like for you to set up an account if you don't have one already. So I've got you just go to create an account and then just use Google to create an account. Once you do, you should see your username pop up here. Then anything that you do, you can save, and it will come up here. So I have all these graphs from other projects saved. And then that way, any work that you do from day to day will be saved. So what you can do is, let's say that you decide there's a certain logo. Maybe it's the Apple logo. So in Desmos here, there is an option to import an image. So you could import this image, and then you can, space it how you would like. So I could increase this. And then I can use this as a guide when I create my parabolas. So for example, if I want to have a parabola here, let's say I'll start in vertex form. So if you remember vertex form, we've got we don't know what the A value is, so I'm just going to put in a placeholder for that. Now I'm going to have my vertex, let's say right about here. So that's at the point -3, 5. So x plus 3, and then plus 5. Now when I put that value just in for A, Desmos does this thing, it creates a slider. So now, ooh, look at that, okay? I have the awesome A value that I can now put in my equation that will give me just the right amount of width. And that is my graph in vertex form that's opening down, and that is wider than the parent function. So that's -1/10, or negative 0.1. There, so I can get rid of my slider. And now I've got my first equation in vertex form. It's not as easy just to place equations in standard form, but what you can do is you can create one in vertex form and then simply multiply. So take the, in this case, x plus 3 times x plus 3 and multiply it out. Then distribute your -1 and combine your 5. And there you go. You would have an equation in standard form. I'm going to do that now on a piece of paper. I'm going to pause my video, and then I'm going to come in and type it in standard form so you can see how it's going to just lay right over my blue parabola of my equation in slot number 2. So now I have that same equation in number 2 in standard form. I simply multiplied x plus 3 times itself. I got x squared plus 6x plus 9. Then I took all of those 3 terms times -0.1. I got -0.1x squared minus 6x minus 0.9. And then I added 5, so that gives me a positive 4.1. And there we've got it. I've got my equation in standard form. So I'll take that off so you can see. Yep. So that is the exact same parabola. So that is just a way that you can go to from vertex to standard form. Now intercept form. So let's say that we want a parabola in intercept form, and let's see. Let's say I want one that's going to intersect the x-axis at -8, and let's try +2. So I'll just start building that. I don't know what my A value is. So, but -8, that means I'll go x plus 8, remember that's opposite, and then x minus 2. All right, then I'm going to click on that A value, and just my slider. A little bit. 0.4. 0.35. All right, now I've got a parabola that is pretty close to that. So again, I'm going to go in and type my A value here. So now I've got one in intercept form. Now it's wider, it is opening up, so that's good. So now I'm thinking about a parabola that it needs to be skinnier. So I've got a couple options, okay? I could do something with the leaf here. I could maybe do something with the bite in the apple. So let's say that I want a parabola at the vertex 5, 6, 7, and then +3. So I'll just start building this equation. I don't know what my A value is. My vertex is at, what did I say, 7, and then +3. I'm going to click and see. All right. So to get an A value that is, where my A is greater than 1, the value of it, it's not going to quite fit in that curve unless I adjust it a little bit. So maybe I'll just adjust this so got it at 6. Let's try 6.5. All right, so I've adjusted back to negative 0.8 because I really like that shape. So I'm going to go for a different location for my parabola that is narrower than the parent. So what I've got is I've got one in vertex form, in standard, in intercept, and then a fourth one in vertex form. But okay, so let's focus on the leaf, okay? So I'm going to have one, don't know, so I'll put in an A value there. And then let's just have the vertex at 0, 5. Okay. Oh, I need to type in, there we go. Okay, so now we're just adjusting. Do you see I adjusted both of those at once? So you could do that as well. Still at 0.2. Okay, let's go negative. And let's move up that vertex. So let's put it at maybe at 1, 8. Okay, so I'm going to go to vertex form. Take out this squared. All right, so x minus 1 squared, and then plus 8. All right, now we're getting somewhere. Good. Okay, so this part right here of my parabola would be the part that I could graph and would be a part, and then I could probably continue this leaf. So putting it all together, then if I move to my art paper, and I'll just put this A value in now, I would have all of these 4 types. I'd probably get rid of this one. And then I've had my one that is in all 3 different forms: vertex, standard, intercept, and then an extra. Ones that open both down and up, ones that were wider than the parent, and then also one that's narrower than the parent. And so on my paper, I would grid out probably a 10 by 10 each way. So with the x-axis, negative 10 to 10, positive 10 to 10. If you look at some of the examples, you can see that they've got, some of them are 1 inch and some of them are centimeter. And then I would graph these, but I would only graph the bit that's going to be a part of the apple. And then I would just continue with the shape, and then I'd pick it up again here with my parabola. And then I would just continue with the shape here, and then the same right here would be the part that I would graph. And then I would label those either by putting the inequalities. Now, I just realized I was doing equations, so I'll start with equations, but now I can change them to inequalities. So this one is opening down. I'm going to go less than or equal to. Well, actually, I'm going to go yeah, less than or equal to. There we go. Okay, so that gives me the shading that would be underneath, and I would just shade the part that's the apple. All right, this one, my orange, so that one also, my shape color is underneath, so I would make that a less than or equal to. And I'd want a nice solid line, so I'm going to include the equal to mark. The purple one now is the one that's opening up. So that's going to be my greater than or equal to. And then finally, my green one, that's opening downward. And so the colored area